Hello everyone, I'm Saeed Haddad and we are today studying on Netflix project. This project is summary is Netflix content clustering project. This focuses on unsupervised learning, machine learning to uncover meaningful clusters of movies and TV shows. Our goal is to go beyond basic matrix and reveal hidden themes in this catalog. The EDA which we are studying on are movies dominated by but TV shows that have grown rapidly since 2015. Most content targets mature adults audiences. Then US and versus India top content producers. Our modeling consists of both k-means and hierarchical clusters. Testing. The impact and the results shows clear and interpretable clusters such as international crimes, dramas, and other genres. Genre. My GitHub repository is Syed hashtag Ilhada. Then we are going right into the code. Here I have imported my libraries. Then I have linked it with my Google Drive. Then this is the information, collecting information and counting the datasets, rows and columns, duplicating the values in df, and here we are using a heat map on missing values. This is a heat map. In this heat map, directories have many unknown values, that is missing values, and caste has much less. Countries has much less, and rating also has one missing value, one or two missing values. Then we are going into variables, understanding variables, that is columns, and describing the whole data set. Then we are using unique values of each variable, checking unique values of each variable here. Then we are doing wrangling of data, that is missing of any values or any duplicated values or anything. Then we are purifying the data. Then here comes the main part of our project, that is data virtualization. In this topic, we are making charts and visualizing the data which we got. Here, first chart I have made in TV versus movies, TV shows versus movies. The whole data set is 100% and 30.9% is TV show and 69.1% is movies. Then the second chart I have made is content added on Netflix over time from 2008 to 2021. Here, number of titles added is much lesser from 2008 to 2015. Then after that, 2015 to 2021, it is increased very much. Then the third chart is on distribution of content rating on Netflix. Here, every type of rating is mentioned, like TVMA, R rating, PG, PG-13, G rating, and number of titles means how many number of movies or TV shows are available. And TVMA has most titles available, whereas UR and NC has very less compatibility. Then the chart 4 describes a top 10 content producing countries on Netflix. That is United States, India, UK, and some unknown countries, including that. Then Canada, France, Japan, Spain, South Korea, and Germany. These are the country versus number of movies or TV shows, number of titles, that is. Then we are moving to fifth chart, that is most common genres in Netflix. That is international movies, the movies that are ja- genre of international. Then comedies, dramas, documentaries, all are listed in here in verses with number of titles. Then the sixth chart of our data analyzation is distribution of data duration, movies duration on Netflix. There are many movies or TV shows that are between 100 minutes to 100 minutes. Number of movies are above 1000, and very less are in between 1 to 50 and 50 to 20, 1 to 200. Then distribution of TV shows by number of seasons. Here we can see number of seasons. Many TV shows has only one season compared to very less TV shows has 15 to 16 seasons. It is a very declining bar graph. Then we are coming to a chart 8, that is content release year versus year added to the Netflix. Means the year the content has been released in world, and the year the data is been added to Netflix. If the year is equal to the Netflix, then it is a Netflix movie or TV show. So here is a bar graph, clustering graph for that. Green is showing TV shows, and orange is showing movies. So after finishing the chart 8, we are coming to chart 9, that is virtualization of rank rating distribution of movies versus TV shows. Here green bar is showing movies, and pink is showing TV shows. The count is from 0 to 1750 and change. For every genre, sorry, rating, the number of movies or TV shows are different. Here we can see TVMA has much of these titles. Then we are coming to chart 10, that is most frequent actors on Netflix. Top 10 most frequent actors on Netflix, and that is in India. That is Avanupam Kher has most content cast, and the least is Ashley Ball and John Casey. Then we are into 11th chart, and that is box plot chart of distribution of movie duration by rating. Here we are drawing a chart duration versus rating. This is this box chart shows which rating has most duration and which rating has least duration. Here we can see TVY has very less duration, and TVMA has much duration compared to that. Then we are coming to chart 12, that is distribution of TV shows season by rating. Here we are creating a data that is containing number of seasons of TV shows, and we are rating it accordingly. Like here, TVMA has much data compared to NR rating and R rating. Then coming to the another chart, that is chart 13. This chart describes top 10 most prolific directors on Netflix. The most prolific one is Jan Studer, and the least one is Lance Banks. Number of titles that is acquired by Lance Bank is above 7.5, and by Jan Studer it is above 20. Here we have created a data set called director counts, which holds this uh, directors data. Then coming to the another chart, that is pair plot chart. Here we have used the pair plot chart in verses with release year and added year. In, th- in this way, we can tell that this the content is Netflix adapted or it is added after the release of the movie or TV show. Here we can see till 2000, sorry, 1950 to 2000, after 2000 or 2020 till 2020, the data has been increasingly high here also from 1940 to 2020. Then we are coming to the part where machine learning is implemented and DS is implemented. That is hypothesis testing. So in this hypothetical testing, we are testing null hypothesis and alternating hypothesis and research hypothesis. First, we have done here null and research and also statistical hypothesis. Then we are coming to data preprocessing and feature engineering. Here we are scaling the data. We are removing the outliners. This is the outliner data, which is here. Then categorical of encoding, categorical encoding. Then data scaling is done here to improve the dimensions of data. Then here we are implementing ML model implementation. In this we are implementing k-means. This is the k-mean elbow graph, elbow method for optimal k. Here we are we are making the chart versus number of clusters versus initial. Then elbow graph for optimal k. In this we are so here we are doing next cross validation and hyperparameter tuning by implementing ML models. So we have created a chart where seed of score for optimal k is represented in which Silhouette score is versus number of clusters, and this is the second model, implementation of second model. Right. So implementation of second model is also almost similar, but it includes other columns, that is other data set. Then this is the implementation of third model. It is using hierarchical data set, and this is a denogram of the data set. Thank you.